people, we are going to do the last topic now, statistics or data, whatever you call it. I hope you still have a hop in your step and a smile on your face, because mathematics is the best. I hope you feel like that by now. I know you've been listening to my voice for hours, but I love you, and I hope you love me by now. So let's go on with our statistics. The table below shows the distances in kilometers traveled daily by a sales representative for 21 working days in a certain month. Now, people, look at this first question. Calculate the mean distance traveled by the sales representative. I wrote that there because that's how you show you are determining the mean. Now, what you do now, I think you all know. You add all those numbers and you divide it by 21. I didn't even add the numbers. I just wrote down, or I added it, but I didn't want to write all of them down. I got the mean, 157,62, rounded, because it was an irrational number. You add all those numbers, divide by 2. I didn't want to waste your time with all those numbers there. There's your answer for the mean. Very simple, level 1. 1.2, write down the 5-number summary for this set of data. Now, people, you know what? At first I thought the data goes like that, but then I realized that the data goes horizontally. So please, I think if you have data like that, take it horizontally. That's 1, 2, 3, 4, 5, 6, up to 21. Now, because we need to arrange all this data in order to find the middle term for the median, the Q1, the Q3, the minimum, and the maximum. Now, I didn't organize that. I just started doing it. But I want to write there that you must remember, write all data in ascending or descending order. Before you can do the 5-number summary, the box and whisker summary, in other words. I did it on a piece of paper because it's a waste of time. You people know how to do this. But I'm quickly going to go through it. The minimum is 131. Oh, but if you look at this, it has already been arranged. I forgot that it was already arranged. Can you see? From lowest to highest. So the minimum is 131. The maximum is 189. Now, Q1. I actually must start with median. The median is in the middle. There it is, 151. Then Q1 will be in the middle of these numbers, and that is going to be there. So you've got to add the 2, divide by 2. I hope you all know how to get to the middle after you've done the median. There's your median. You close it. Then you close that one, 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 close that one, you close that one, and what is left is those 2. Can you see? It's an even number, it's 10. So there will be 2 numbers for the Q1, which you add and divide by 2. So that gave me Q1. Then the median I did, Q3, now you go from there to the end. And the middle there is 172 and 174. You add them, you divide it by 2, and you get 173. Now, what did they say? Write down the 5-number summary for this set of data. That was the only question. And there's your 5-number summary. Lowest, highest, Q1, median, Q3. Let me just go up. There it is. Lowest, highest, middle, Q1, Q3. Next question, 1.3. Use a scaled line to draw a box and whisker diagram for this set of data. Now, I was so lazy, I didn't draw a scale diagram. I just did this. I actually said there, draw it on scale. Draw it on scale. I didn't do the scale. do your scale here at the bottom. Let me just get something to draw a line with. Do your scale here. Because it is important for the skewness to have the correct scale. I just decided that I'm going to do this. I guessed the distances. Okay, but you mustn't guess. Please, you mustn't guess. You must draw a scale there. And the scale must be from 130 to 190, I should say. 130 there, because then 131 will be there. And 190 there, because then your 189 will be there. And then from 131 to from 130 to 190, you can make it intervals of 10, and then get to your 190. Use your ruler. But I didn't have enough space, so I just decided to draw this here. If you have the 5-number summary, this is the most difficult part, it's very easy to draw your box and whiskers there. So this is your minimum, this is your maximum. This is your median, Q1, Q3. And people, I guess the distances, but I think my sketch is quite on scale, although I didn't do a scale there. There you do your scale, from 130 to 190. Do it in an easy way. Take intervals of 10. Use your ruler. You can use the whole page. You can use 10 centimeters to get there. It's only 6. So you'll have to take 2 centimeters for every, I'm not going to do it now, 140, 150. Look how accurate I was. 160, 170, 180. It's only the 990 that's a little bit too close to that. There's your scale. Can you see it? And now you draw your box and whisker. You draw the box there after you've plotted your Q1 and Q2 and your median. Draw the box around that. Then you draw a line to the minimum and a line to the maximum. Because the box and whisker goes about median, Q1 and Q3. Okay, people. The next question, comment on the skewness of the data. Now comment, that's all they asked. You say positively skewed to the right. Positively skewed to the right. There's more space here on the right hand side than you have on the left hand side. So more data in there, less data on that side of the mean. Only you say positively skewed to the right. That is your answer for that one. Now let's have a look at 1.5. Calculate the standard deviation of the distance traveled. Well, people, I'm not going to do it now because you've got to put all those numbers, all those given numbers, into your calculator, follow your rules, and you will get to your standard deviation. I think you all know the little recipe for that. I hope so. And if you don't know, you go to your teacher, you say to your teacher, please explain how to get the standard deviation to me once again. It is only 1 mark for a lot of work. People, I really don't know why they give such a lot of numbers. And then it's big numbers also. Because if they give less numbers, the method stays the same. But they gave all those numbers, so we must be satisfied and we must do it. It's going to take quite a while to put all those numbers onto your little calculator. So that is what you'll get. If you go along the recipe, you will immediately get to the answer. Right, people? 1.6. The sales representative discovered that his odometer was faulty. The actual reading on each of the 21 days was p kilometer more than that which was indicated. Write down in terms of p the actual mean. Now, people, all these numbers, you're going to add 30 to them because his odometer was faulty. You add 30 to all of them. In other words, your mean will only change with 30. You will add 30 to your mean. You won't have to work out the mean again, please, because it's the same number that was added to your mean all the time. So this is your mean, and then you add the p. That is the difference after he realized that his odometer is not right. And it stays constant with each of those distances. So the mean will only move up by p units. Okay. Right, let's have a look at 1.6.2. 1.6.2. Determine, let's go down to the question, the actual standard deviation. Now you determined the standard deviation, there it is. Now the actual standard deviation will stay the same, because of the fact that the same number was added to each of those distances. It will stay exactly the same. People, I'm glad I did this with you, because this is a funny question, this one with a P, and now you see what influence it will have on the mean and the standard deviation. So if you get something similar, you will, I hope, remember what we did in this specific sum. Right, let's go to another data question. You know, data is very easy. I hope the learners that are struggling to pass really make a serious attempt to get good marks in data, because they ask the same things over and over again. And I'm trying to, in this revision, to do one of each of those things that they normally ask in the papers. The histogram, the speed of 55 cars passing through a certain section of a road are monitored for 1 hour. The speed limit on this section of the road is 60 kilometers per hour. A histogram is drawn to represent the data. This is the speed, and this is how many people from the 55 cars, what speed they drove. Let's see. Only one drove between 20 and 30. 7 drove between 30 and 40. 13 drove between 40 and 50. 70 between 50 and 60. 9 between 60 and 70, that's me. 5 between 70 and 80. 2, 80 and 90. 1, 90 to 100. So one of them, no, 3 of them, 4, 5 of them, 8 of them really speeded quite hard in that section, because the speed limit was 60. Right, let's go on and answer the questions on this graph. They said, identified the model class of the data. Model class means the class with the highest frequency. And that is the class with the highest frequency. If you add up all this, it's the frequency, so it should give you 55, which is the number that they gave us at first. Right, so the model class is between 50. Why did I write? Oh, people, I know it's between 50 and 60, but I wrote 60 and 70. X larger or equal to 50, smaller or equal to 70. Ignore that answer there. That's the model class, the one with the highest frequency. Okay, next question. Use the histogram to complete the cumulative frequency column in the table. Now, people, that's your frequency. I've got a table here, and you've just got to complete the table. You don't have to go back to the graph, actually, because they gave you the frequency, and there it is, 1, 7 on the graph. Now, how do we determine the cumulative frequency? You start like this, 1, then you add 7, it gives you 8. Then you add 13, it gives you 21. 21 plus 17, 38. 38 plus 9, 47. 47 plus 5, 52. 52 plus 2, 54. 54 plus 1, 55. And it's right, because there's 55 cars. They gave it to us right at the beginning of the sum. Now let's go and look at the next question there. 2.2.2, draw an ogive, a cumulative frequency graph of the above data on the grid. They gave a grid. Now I didn't have the grid. So I went there and I draw my own ogive. So let's have a look at that. And I was shivering there from cold and I drew an ugly, ugly graph. But there it is, people. It's always, when you draw the ogive, the cumulative frequency here and the speed there. Those are the speed intervals. Can you see that there? When you plot points, you always plot it on the last number in your interval. So, let's have a look. 1, it's a cumulative frequency. 1 goes between 20 and 30. So the 1 is there. That's why I had to depict that out, because the graph made a bend like that. 20 is 0. So we start at 20 with a 0. At the end of that class, we mark the 1. Then at the end of class, where we've got 40, we've got an 8 there. End of class, where you've got 50, we've got a 21 there. End of the class, where we have 38, this is 1, there it is, 38. I didn't write all the coordinates. You don't have to write all the coordinates, people. Then, end of this class is 70, and there's your 70. And this one is 47, it's over here. 70, 47. And then 5. At the end of this class with 80, we've got 5. No, not 5, 52. It's going to be more or less there. And then at the end of the 90, we are going to put a 54. And then at the end of 100, that class, you plot at the end of the class. Mine is a little bit skewed because I did it freehand, but that's the ogive. Okay. They always give you a grid for that because it should be very accurate, because they will ask you questions from that graph. And that is the next question, 2.3. The traffic department sends speeding fines to all motorists whose speeds exceeds 66 km per hour. Estimate the number of motorists who will receive a speeding fine. So what are we going to do? We're going to go to 66 there, up to the graph, and the correct answer is 44. So in other words, 44 people did not exceed the speed limit. Can you see that? Only those people who drove faster than 66, they exceeded the speed limit. So 44 did not exceed the speed limit. It was 55 cars. So how many did exceed the speed limit? 55 minus 44. Be careful, people. I'm sure a lot of you would have written 44. But it's the people who exceeded the speed limit. So it's those people who exceeded it. It's not the people who drove in the speed limit. So please make sure that you are sure what they want from you. I wrote this little tip there. You plot the points at end of each interval for the ogive. Right, the people, that was our frequency table and our ogive. The one that is left, there's one left, stopped at the right time, no? One left, people, only one. And this is the scatter plot. Then we've done all the typical questions that they can ask. The only thing, people, at the scatter plot, in grade 12, they will also ask you for the equation of the regression line. But that will be done by the person who is going to do probability with you, okay? So I left that question out in the scatter plot. But you are going to get the regression line. I promise you. And it's going to be part of your scatter plot. Okay, so have a look at this scatter plot. Only the questions that I do here is 3 little questions. There's your scatter plot. They are comparing the mathematics marks to the accounting marks. You see, mathematics is more important. It's on the horizontal axis. But I'm making a joke. You normally put your top of your table on the horizontal axis, and your accounting will then be on the vertical axis. So, but I think it's because maths is more important. Wonderful subject. That's why they put it there on top. Don't you think so? I hope you agree with me. There's your scatter plot. Now they said, calculate the mean percentage of the mathematics data. These are all percentages. Okay? So all you need to do, you add all the percentages and divide by how many learners? It's for the mathematics. 2, 4, 6, 8, 10, 12. 12 learners. 12 learners. So you add. But how do I get the percentages? It's there. You don't do it. Sometimes they leave that and they say to you, you must read it off from your grid. And then it's quite difficult to be accurate. But then the grid must be much bigger also. That's how I feel. Okay. But they gave you the mathematics percentages. All you do, you add them for the mean. And there I actually showed it to you. I was too lazy in the other one. And then you divide that by 12. That is your mean of the mathematics mark. So the average of these children, wow! I hope you can brag with an average like that at the end of the year. 68%. Maybe they only took the strongest learners because it's only 12. But still, people, what a wonderful average. 1.2, calculate the standard deviation. Okay, you use your calculator, and that was the standard deviation. 1.3 is the actual sum that I really want you to understand. There's your standard deviation. And now, people, we are going to see how to determine this 1.3. They said, determine the number of candidates whose percentages in mathematics lies within one standard deviation of the mean. Now, this is what you do. You take your mean minus your standard deviation and your mean plus your standard deviation. And this is going to give you 49,58, 86,42. Between those two numbers, we will determine the number of candidates whose percentages in mathematics lie within one standard deviation from the mean. It's very difficult words, those, to understand. But please, this is how you do it. So now we take 49,5, 86, and we go back there to our table. And now, and this is also in the mathematics, the most wonderful subject on earth. 49 and 86. Let's have a look. Which of these numbers falls between those two numbers? 52 is above 49, so this is 1. 82 is also between those two numbers. 86 and 49 are the actual numbers. 49 and 86. 93 is not between those two. 95 is not between those two. 71, yes, it is between those two. 65, it is there. 77, it is there. 42, it's on this side of the 49. 89, it's on this side of your 86. 48, this side of 49. 45, wrong side of the 49. 57 is between those two numbers. So you look for numbers between those two numbers. And in this case, I marked them 1, 2, 3, 4, 5, 6 of them. What was the question? They said, determine the number of candidates whose percentages in mathematics lie within 1 standard deviation of the mean. The number of candidates. And how many are there? 6 candidates. There you have your final answer. 6 candidates. This one, please try to remember this one. It's a very easy way to do this sum. Okay? Right, people? I'm done. And I think you are also done and tired and a bit back, we say in Afrikaans, because it has been quite a long time that I've been trying to explain work to you. But I really hope that it helped. I want to say to you, good luck to each one of you for the June, September, and final exam. You will be in my prayers. Love you, people. After all these hours, I really love you because you know what? I don't have anybody in front of me while I was doing this. But in my mind, I saw learners who are so eager to do their best and to be the best. Good luck for you all.